Hello, welcome to SledgeCast number 2. This is basically a code review of Prometheus. Last time we were looking at Prometheus, we took a look at some of the basic documentation, the README, that kind of stuff. We looked at kind of how service discovery works in Prometheus. And we looked at some of the architectural structure of Prometheus, which is actually conveniently placed in this diagram in the README. These orange ones here, Alert Manager, Push Gateway, Server. Alert Manager is a separate project. Service Discovery is built in. What we're going to look at today is we're going to try and take a look at the storage system of Prometheus and maybe the Prometheus QL code. So if we look up here, we have CMD, config, console, discovery. I thought there was a storage. Yeah, there's a storage directory here. So let's go in here. Alright, so we've got buffer.go, buffer test, fan out, interface, and no op. So no op is usually you call function, and if there's some case, then it does nothing. So let's look at this interface. What's this? Okay. So we got some errors. This is just a standard Go error that they've made a constant out of. Okay, so storage is an interface. It's embedding queryable. So queryable, basically when you embed something like this in a Go, struct saying, is that what that is? I'm pretty sure it is. We'll try to find out what this is, but I'm pretty sure it's an embedded thing, so it's kind of like inheritance in Go, but not exactly. But you can basically anonymously embed something into a Go struct or interface, and it will inherit all those methods. So you could call storage.queryable.query or something. And then we have start time and appender and close. Is this queryable? So that's an interface. So this interface is inside this other interface. New query on the storage. It has a context, a mint, a max, and returns the query or an error. And there's another interface. So we got some nested interfaces here. Okay. So the query basically does selects. You pass in some parameters, and you can have a select method, a label values method, and close. So this looks like it's the this file is basically the interfaces for storage in Prometheus. So as long as you meet this interface, you can define your own storage method, and it'll compile and work. Select param specifies parameters passed to data selections. So we go N64. Okay, so here's like the step size, and here is function string. Alright, so I'm not sure what that does. Queryable func. So it lets you treat normal functions as queryable. Basically a wrapper that makes it a queryable. Okay, and you pass, I would have thought you'd pass a function here. Alright, so we got a query function on F. Okay, So this is basically, this is a function. Type queryable function. So I'm learning new Go here because I haven't seen this syntax before. I wonder if it's defining like a function of some kind. Because usually you do function, receiver, name of the function, but this is type, queryable function. Oh, the type is a function. So what you can do in Go is you can be like, wait, this open. Yeah, there we go. Apparently that did nothing. Oh, here we go. So what you can do go is you can do function, or you can do type. I don't know, banana, and this could be a struct, and then you can define various fields like length, int, weight, int, that kind of stuff. Apparently we can also do is you can type queryable function, and then you can set this to be a function that takes a banana struct like this, and then this your type is actually a function. There we go. All right. So I guess it's like a function type. Alright, so we have an appender, which batches appends against the storage. So basically, you got lots of writes coming into your storage system. You want to, maybe you only want to write like 1 kilobyte at a time instead of every 64 bytes or something like that. So what you do is you basically have some kind of queue or an appender, and it builds up some things and then it commits them. This is a lot like a buffered writer, or there's actually a buffered writing set up in Go for writing files. This is kind of a similar thing. And the methods add some kind of set of labels, timestamps, and floats. Interesting. So we're adding something. There's some group of labels. There's this labels thing, and then we have an int64 with a T and a float64 with a V. So usually this would be a timestamp, and this is a value, and the labels are basically what tells you what metric it is. So this is basically batching single metric updates to the storage. And this add fast, not sure what that does exactly, but it has an extra int64 in it. Alright, so we have type series set. Next, add an error. So that's, looks like it's a iterator of some kind. Contains a set of series. Single time series. Type series. So it's a single time series. It has some labels and has an iterator, which is a series iterator, which is defined here. So we want to iterate over a time series. I'm guessing this is like, let's say we have one metric of like requests per second, and we have that data for like a month. Well, you need to somehow be able to go through different data points over that month. And I would guess this is used to like get what's this metric over this day or something like that from the database maybe. Series iterator. So let's take a look. So we look at the interface. So, we have so these two directories, tsdb and remote. tsdb probably stands for time series database, but there's only one file here. So let's look some more. How big is this? This is 300 lines. Okay, got model, storage, import storage, which is just the code from the parent directory. So we got, look at that stuff for a second. Getting, sorry. Alright. So this is tsdb.go. There's some kind of set the storage. So it's doing the mutex, and then we're setting some value, the adapter. Oh, it's a ready storage struct. And we're taking the DB as an argument to set. So we're basically just setting our DB at some time. Well, it's a time margin. So a time margin is basically like a margin for error, how accurate we want to be in our time measurements. If we're setting and getting the storage, So this is getting a TSDB, and this is getting an adapter. Implements the start time, implements the storage interface. So we were just looking at that. Okay. X of storage.get. So like setting up the start time area. Alright, so here's an implementation for TSDB of Courier. X.Courier, where X is an adapter on a ready storage. So S is a ready storage, and if we call S.get on ready storage, so get, that gives us a TSDB. Okay. So we have an appender, implements the storage interface, Courier, close, also part of the interface. So let's take a step back, go back to storage, interface. Just want to look at the interface again, see what methods are on it. Yes, we have queryable start time. Interesting. Yeah, the oldest timestamp in the storage. And appender returns a new appender against the storage. Okay. And then close, this cleans everything up. So we're just looking at implementations of this that are part of the tsdb.go. Okay. Wall flush, min block duration. Wall is write ahead log. Basically, when you get appends or whatever to your database, you write them to a log. It's just a file with just putting lines of text in. Because it's doing synchronous writes just to the end of the file, it can write really fast. So if your service crashes before you can write and append to your actual, whether it's a binary tree or whatever they're using internally here to store stuff so they can query it. While that's being written, it'll be in the wall, and that will basically give us a little more durability if Prometheus crashes while it's writing things. We can start Prometheus again, we can see the wall. If we need to, we can rewrite that data to our storage. And it's just a really nice way to have a quick, like very fast, very low overhead way of getting a little bit more durability around writes when they're in flight. Okay, interesting. Min block duration. So that's basically the smallest duration of a persistent block. Okay. So we have heading compacted block. And then retention, how long to retain data, no lock file boolean. And that's just a toggle on whether we have a lock file, I guess. So what's up here? Alright, so this is just implementations of the storage interface on a ready storage struct. So ready storage is actually it's tsdb dot ready storage, but that is, I think, our entry point into the storage interface, essentially. So we skip past the ready storage implementation, the adapter, the options for the adapter. Maybe I'm not sure whose option it is. Probably the DB options. Okay, so open. It's a new storage backed by a TSDB database that's configured for Prometheus. So we've got a path, a logger, Prometheus registrar, options, returns a TSDB reference and an error. If ops.min block duration is greater than the max block duration, that sets them to be even. So it's basically saying if your minimum duration is bigger than your maximum duration, that doesn't make sense for the program, so it's just going to set them to be the same. It's going to set them be all equal to the min block duration. Interesting. So we have start with the smallest block duration and create exponential buckets until they exceed the configured maximum block duration. So basically, create blocks with a minimum duration, and then create exponentially larger buckets until we get past the max duration. Okay. So we have TSDB exponential block ranges, and then we're giving it an N64 of the min block duration converted into milliseconds, it looks like. And then we're doing a 10 and a 3 as arguments too. I don't know what the 10 and 3 is, but let's see if we can find exponential block ranges. It's not in this file, but it is .tsdb. What's up here? We're in package TSDB. We're importing Prometheus TSDB. Okay, interesting. So TSDB is actually another GitHub project. So I thought the actual storage was implemented in this directory, but it's probably in this TSDB project, and this is just a wrapper that consumes that and basically handles the actual storage for Prometheus. So exponential block ranges. So TSDB has all the low-level code for how we're actually storing the time series database. And then this storage group of packages handles how do we use the time series database to store Prometheus's data. So we're creating a TSDB, so let's just take a quick detour. Right. Let's pull up Prometheus. Where is TSDB? Okay. Alright, yeah, this is about as much stuff we'd expect to see. We could expect to see a lot of stuff. Interesting. So yeah, they added this in the 2x release for Prometheus. We've got a design document and a video. Okay. Some recent activity. Interesting, okay. So this is where the DB is actually implemented. Let's just take a look here. This is a nice blog post on why they wrote their own time series database to back this, basically. We're not going to go through that right now. Alright, so basically we create a storage. The storage is storing like a time range, apparently. And it has kind of exponential buckets. So there's a bucket for a short range of time, and then there's a bucket for a larger range of time and a bucket for a larger range of time. I'm not sure what the background for that is. And we're probably going to want to go through this TSDB repository later and kind of figure out what's going on, how does that work, what is it doing, all that kind of stuff. So this is implementing the adapter interface. Start time. I really am not sure what start time does exactly because it's not like my first thought. It's probably a time series database thing because we are recording data in blocks at time. Yeah, but this isn't something you would see if you were doing like a NoSQL or just a SQL database, MySQL. This isn't something you see very often. Usually you don't need to know what the start time is. I mean, that's my perspective at least. Maybe you do need it, it's just covered up by the software. And since we're implementing, this storage database is actually in the same process space as Prometheus. It's not run as a separate process. So that could add more complexity too. Here's the query method on adapter. More things. Here's a select method. Underscore star storage dot select params. This is another bit of Go syntax I haven't seen before actually. This is underscore is usually like an abyss or an empty void. You don't really care what that value is. If you can assign things like this here. This is just dropped from memory. Nobody really looks at it ever. but as an argument it's kind of strange. It's possible that we want to meet this interface, the select interface, which I think is just in Courier, but we don't actually need this argument at all, so we're just going to drop it. So we got some labels. This just means you can put a bunch of labels in here. It could only really be the last argument, but it lets you put basically a whole bunch of pointers to label matchers. And this returns a series set, which presumably is a set of time series data. Let's see. Maybe an ordered set of data points, is my guess, based on the labels you gave it. So MS, we're making an array of TSDV labels matchers. Looks like it's maybe it's initializing at 0 and its length is of OMS. I didn't think that was an argument to make. This is a version of make I haven't seen before actually. So make an array like this makes you a slice. Usually you can pass the length in. But this is also a length. So I'm not sure what the 0 is doing. Yeah. One thing I probably need to look up is where the code for make is written. Let's look at that package and see a little bit more of what's going on. So this here, they're just building up a for loop. So they're just appending all these converter matchers onto MS. Range OMS. So yeah, they're basically going through OMS and stuffing each one into this MS variable. Alright, then we're calling a select on q.q. So this is a courier. And then we're calling basically this is an embedded struct in it. And then we're calling a select method on that. So it's basically courier.queryable.select, and then we're passing these matchers into it. And then that check for an error from that, and then we return our series set that we got here. Alright, so we got label values, series set, TSDB series set. So it's just a wrapper around some kind of primitive from the TSDB library. So this set here has a next error and that method, which are just wrappers around the TSDB series set. I guess they just wrapped this because they didn't necessarily want to expose everything that a TSDB series set has. They don't necessarily want their users to be calling or just have access to the TSDB. They don't want to expose that, so you get this wrapper that gives you what you need, but doesn't let you really change anything fundamental. So we got a series, it's another wrapper, more methods. And this appender is the same thing, we're just wrapping something in the TSDB. This actually makes me wonder if they pulled out a lot of functionality into this Prometheus TSDB library and basically replaced some stuff, but they wanted to keep the interfaces the same, so they just wrapped a whole bunch of stuff that they re-implemented in a lower level. It's not really that unusual of a practice because you don't want to expose like database internals. Like this is an app where your database is running the same process, your code base, let's say you're like writing Korean code or you're writing code that handles the jobs for collecting data, because Prometheus is pull based. You don't want to be having methods that are affecting the database internals at your fingertips, really. You don't want your autocomplete coming up with that. You really just prefer to have that stuff not be accessible at a higher level. So here's this convert matcher. Takes some labels and then converts them into TSDB labels. And here we got some of the cases. So we have match equal, match not equal, match a regex, and match not a regex. I honestly don't know what matching not a regex is. Maybe it's like a normal string match. Okay, interesting. So these not match not regex and match regex are both actually regexes. Interesting, okay. I was just going to check to see if they use the same regex string, which they look kind of similar, to be honest. They are similar. In that case, I don't get it. You go into a regex whether or not you're match regex or match not regex. Oh, okay. Interesting. So what this does basically is it's just a not. So if it doesn't match the regex, then it returns you. So not really that crazy. I just missed this a little bit here. It's just like the opposite of what you would have gotten if your regex had been matched. And then this converts the opposite direction to the labels. It's just basically swappers for, or converters from TSDB labels to Prometheus labels. Okay, so this is really just TSDB.go. That's a wrapper around TSDB, which is actually probably thousands of lines of code. I don't know if there's an easy way to see it here, but there's definitely a lot going on there. What's this do? Nothing. So more storage. This remote is probably just a hook into another storage system that's like, what is that one called? One of the other, like a standalone process. It has a codec in it to convert stuff. Queue managers, read, writes, storage. So I'm pretty sure that's what that stuff is. This buffer to go is probably a write buffer implementation. Yeah, buffered series iterator, new buffers, reset, peek back, seek. Yeah, these are just standard buffered operations. Next. One thing that I really appreciate that's in code is when you have some writing here that explains what this file does on top of like storage.buffer, which is okay, it's called buffer and it's in the storage package. This license here, great, really nice. I really would like some text like right here or maybe right here that says buffer contains functions that handle some kind of buffers that are for this purpose. Instead of like, here's some buffers. Alright, but I don't know why we need a buffer at all. So it's kind of point. I really like that kind of context at the top of the file instead of this license. I mean, you gotta have licenses, but the context is probably more valuable to me than this. Let's just skim through this. Looks like pretty normal buffering things. Some kind of ring structures in here. It's probably a ring buffer. Or you can go backwards in it. Some rings, okay. You may just support array buffers and ring buffers. Alright. I really would have liked to know, like, what is this buffer for? But I don't. I can go to buffer test, I guess. So in Prometheus, they're actually using table-driven tests, which is a fun way to do tests in Go, because in Go, you can define anonymous structs. So basically, this bit here is saying cases equals a slice of structs which have an input, a delta, and a size. And then this bit here is basically how you normally create a slice of just whatever. So I just defined the type in this little bit of code here. And now here's the value of cases. So these are basically my test cases. We're testing a sample ring. We're inputting these ints, we're inputting these ints, we're inputting these ints. The delta is going to be this, the size is going to be this. So then we have our, basically our test case, which is all this code. So for a range of our test cases, which we just defined up above. So for each test case, we're going to create a sample ring buffer with arguments of c.delta and c.size, which is our case. And then we're going to define our inputs. And inputs is basically equal to the samples. Oh yeah, so here we go. For range, for basically everything in our test case inputs. So this is just one test case. For each of the inputs, we're going to append that input and a sample which we're creating here, which is a time and a random float. So we take those inputs. The value of the input is basically the timestamp, and then we're creating a v, which is just some random number. So this is all our prep, and then for here, for the range of the input, which is a timestamp and a value, we're going to call this add method on the ring buffer, and we're going to call r.samples. And we're just calling this, we're calling all of this for each time. Range input, so this is just one test case. Buffer equals r.samples. I don't remember that method, but we probably saw it in the buffer file. And then this is just the entirety of input from the beginning to I. And I is here. So this is the index in the input. So we got sold, which is equal to the value of the range of input array from 0 to I. Found equals false for drop the index BS in range of buffered, which is just the samples. If bs.t equals sold.t and bs.v equals sold.v, found equals true. So we're just checking to see if something's in this list. Okay, if sold.t is greater than s.t minus c.delta and not found, then we fail the test. If t is less than s.t minus c.delta and found, so we're just catching for basically the stuff that shouldn't be happening in how you go around the ring buffer and values are overridden, etc. And here's the buffered series iterator. And it's a little bit less table driven. More of what you would expect in a normal test. And then they've got some, looks like require, I'm not sure what that is. Yeah, so require is part of testify, which is basically a test matching package. Alright, I went too far. Alright, so the other thing we got in here is no op. Let's just take a quick look. Alright, not too much is happening. Yeah. So no op is basically a implementation of the storage interface that does nothing. It's got all the methods and none of them do anything useful. That's probably used for testing or if you want to run Prometheus without a storage engine, that kind of thing. So let's go fan out. Alright, so we got storage, container heap, context, same logs as everybody else. Prometheus is labels, package. So we have a fan out struct, logger, primary, and secondaries. They're all storage. So this is like we're fanning out to multiple storage destinations, I guess. And our secondaries is basically just less priority storages. Yes, new fan out turns a new fan out storage which proxies, reads, and writes through to multiple underlying storages. So basically, you use the fan out as a layer on top of your actual storage thing, so you can write or read multiple storage objects. Or I guess structs. That's just the constructor. It looks like fan out actually implements the storage interface. So we've got the courier, we've got the start time, we've got the appender, we've got the close, we got the add. So basically it has all of the same methods that are in the interface, except this, so it's a storage that multiplexes over other storages. or I guess it's not multiplex, it's more like, well, it's literally a fan out, where it's fanning out to multiple storages. So you kind of get a storage pyramid where you have the fan out storage on top, and then you have underneath you have maybe a remote storage or a TSDB storage or a no-op storage, and you can replicate those messages to everything. And it also does merging, so you can query against multiple backends at once, and it'll merge the results together. Okay, select, and this is more the very same interfaces. We're going to see those methods a lot of times. Utility method that merges some strings for us, an array of an array of strings, and returns an array of strings. Merge two string slices, so a bunch of utilities that implements the interface. Merge a series set, so basically there's a bunch of different things that we're getting. Like when you do queries in this system, you get a series set back. So if you query against multiple storages, you're going to get multiple series sets. We're going to want to merge those into one series set, so our consumers can't tell that we're multiple storages instead of one storage. Because the whole goal of this fan out is basically to opaquely cover up the fact that we have multiple underlying storages and act like we're just one. And that's actually a very common problem in the software engineering in general, where you have multiple databases and you want to have your consumers only see one database. You don't want to expose that to your consumers. So here we have a series set heap, which is a type alias on a series set, essentially. It's an array of series sets. I'm a little bit confused why it's called a heap. Maybe because it has push and pop methods. Okay, interesting. So the fundamental, like the base type, is a slice of series sets, but it has functions on it that act like a heap. So it's basically a heap that's backed by a slice. And you have push and pop and length, swap, all those good methods. A merge series, I'm not sure what that is. Maybe it's just definitely just iterating, and it returns labels. Merge iterator. So basically we have a bunch of like merge types, which is I guess they just handle things that are merged. Anything else in here that's interesting? Series iterator heap. Okay, so it's a series iterator that acts like a heap. It's exactly the same as the other one we were just looking at. Alright. So just to sum up, this is the Prometheus storage directory in Prometheus. What we found out that Prometheus is backed by this TSDB or remote storage backend. We have a number of functions like the storage interface that Prometheus uses when it wants to communicate with its storage backend. This TSDB is basically an adapter between the Prometheus storage interface and the library TSDB, which is part of Prometheus and implements the actual time series database storage. They pulled it into another repository because time series databases are a little bit general. Prometheus is focused almost entirely on metrics and monitoring and fetching data, so it makes sense to pull it out. It could be reused for other things. And then we have just like the span out. That's a useful utility if you want to have multiple backends, or let's say you want to let's say you're running like 4 Prometheus servers because you want to have extra durability, or you want to have more data storage for whatever reason. You can do this fan out and basically treat those as one storage backend. So yeah, that's our review of the storage directory in Prometheus. Next time, I think we may take a look at this TSDB, just because it's probably got some interesting code in there, because they're doing these time series, and they're doing blocks, they're doing tombstones, they're doing write-ahead logs, compaction. There's a lot of stuff going on here. Honestly, this might be its own set of screencasts, to be honest, but Maybe I'll do some research to see how deep it is, and whether we should do that or go into some of these jobs where how does Prometheus fetch the actual data? Because we looked at this service discovery last time, and we see how is Prometheus getting the locations to get the data from, but we haven't looked at how we get the data yet. We haven't looked at retrieval yet. So we may look at retrieval next, or we may look at TSDB next. I'll ask some people, and we'll get an idea there. So yeah, thanks for listening to screencast number 2. We've gone through some of the storage stuff in Prometheus, how we're storing our data. We're using TSDB, which is a whole other project, and we've got some nice wrappers on top of it. Alright, so thanks for listening, and this has been the screencast. So let's see if I can stop this. Alright, I'll stop this one.